Hey guys, this is Satyajit Pattnaik and welcome back to my channel. Today's topic is going to be one of the favorite topics in statistics, which is going to be outlier detection. Now we'll talk about outlier detection and anomalies. What are they? How do they occur? How do we handle? Everything will be covered in this video. So let's get started. So what is an outlier? An outlier is a data point that is significantly greater or smaller than the other data points in a data set. It's useful when analyzing data to identify outliers. They may affect the calculations of descriptive statistics as well. Okay, and outliers can occur in any given data set in any distribution. What does that mean? That means, for example, we are analyzing the height of various people. Okay, and let's say the heights are like 171 centimeters, 173, 174, 176, 180, and there is a certain spike of 90 centimeters. That means there is a sudden fall, or else 170 to 175 range, and then suddenly we have somebody with 220. That means some of the data points are very high or some of the data points are very low. Okay, it could be a regular problem, like it could be a known issue, or it could be because of human calculations as well. Okay, so this video we will be covering about what are the different types of outliers and how do we identify them and how do we get rid of them in the data analysis part. So let's get started. So the easiest way to detect them by graphing the data or by graphical methods such as histograms, box plots, and the normal distribution plot. Okay, outliers may indicate an experimental error or incorrect recording of data. They may also occur by chance. So we don't know what's the source of that. How do they come? We don't know. But outlier detection and analysis is very much important because sometimes we like to keep the outliers because we don't want to miss the information, and sometimes we want to get rid of the outliers. So it's very important to understand how do we identify outliers, and then slowly once we have the business understanding and the problem understanding, we get to know that this outlier is because of this, then slowly we will be able to understand that. Of course, this video is aiming for you to understand as much as possible. You might not get 100%, but let's see how much you get. Okay, so the next slide talks about one of the small examples, which is the time taken to process a sample of applications. You can see all of them are in blue, and there is one point which is in red, which is an outlier, which falls very away from the rest of the data points, right? It's clear that one data point is far from the rest of the values, hence it's called as an outlier, or else people call it as anomalies as well. Okay, how to detect outliers? There are various methods to detect outliers. We shall be talking about some of the methods, and then we'll also be discussing about some of the advanced methods. We will see how much can we cover in this video. Okay, now detecting outliers. First step is going to be standard deviation technique. You can see this graph. This graph basically shows me the normal distribution and how the data is split across various standard deviations. So this is your first standard deviation, second standard deviation, and third standard deviation. People who don't know about normal distribution, maybe I'll create a separate video for that, but I will make sure in this video you're understanding most of the concepts. Now, normal distribution is basically, so the first standard deviation will have 68% of the data. Second standard deviation is 95%, and the third standard deviation is 99.7, which means any point which lies beyond your third standard deviation, so standard deviation mu plus mu plus 3 times standard deviation beyond that, or mu minus 3 times standard deviation beyond that, which is your 0.3%. Those are basically your outliers. So this means 99% of the data stays within the range of mu plus minus 3 standard deviation. Okay, now what is standard deviation? Standard deviation is the measure of how spread out numbers are. The symbol is sigma. The formula is easy. It's square root of variance. Now, what is variance? Oh, so much of statistical terms, right? But we'll see what is variance. Variance is nothing but the average of the squared differences from the mean. Looks a little bit complicated, but I will make it sound easier. We have an example. So there are various heights at different shoulders of the different breeds of dogs. Of course, whole credits of this particular example goes to mathisfun.com. I will also leave the blogs link in the description below so that you can go through. But in this video, we are making an entire video on this particular example. So I think you will have a very good understanding on outlier detection. So let's say I have 5 dogs, 600, 470, 170, 430, 300. Let me just delete all these things so that we will do it from scratch. Now, this is nothing but the first step is to create the mean value, to find the mean value. Mean, which is a statistical term, the normal term is average. So finding average is very simple. Sum all the numbers divided by the number of observations. Simple. So if you see the sum of B3 to B7 is basically 1970. Now, if you do 1970 divided by 5, how much? We are getting 394. So this is my mean value. Okay. Now, next step is to calculate the x minus mean. Okay, which is your xi minus mu. If you consider mean as mu, mean is basically considered as mu. So this is your mean value, the second part. Okay, and we are just finding the x minus mean. We'll talk about the formula as well. What is x minus mean? It's 600 minus 394, right? I'll do the same things for all the steps. Simple. Oh shit. So we have to do B3 minus BC3. Okay, and then we just drag it. Yes, we get all the numbers. So x minus mean. Now I will be doing square of D. That means square of x minus mean. So we are doing this whole part. Okay. So how to do that? Of course, D3 into D3. Okay. If I just autofill it, this is how things work. Simple. So here I'm doing a sum of E3 to E7. That means I'm summing up this particular column. So this part, the summing up part. Okay. Now, after summing up, what I have done is I have taken a square root of this value. So this is my variance. You can call it as a variance. And this is your standard deviation. Okay. If you want to calculate standard deviation using Excel, how to do that? Standard deviation. So there are 2 types of standard deviation. I'll talk about that. So we will be using standard deviation for an entire population. And then I just do B3 to B7. You can match the numbers. The numbers are matching. Okay, so this is all about standard deviation. Now, standard deviation's formula is this one. This is basically your variance, and the standard deviation is nothing but square root of this. Okay, if I just add a square root, it becomes your standard deviation. This becomes your square root. Okay, it's okay. Square root of this one. So this is how you calculate the standard deviation. Now going back to the example, so here you can see the first step is going to calculate the mean. So we calculated the mean, and then we calculated each dog's difference, which is the x minus mu, and then we added up the sum value, added up the square values to 1704, and the standard deviation is this. Now what does that mean? The good thing about the standard deviation is that it is useful. Of course, it is useful because standard deviation is something which we use on a daily basis, on a daily problems. Very important concept, standard deviation mean. Now we can show which heights are within one standard deviation. Now you can see the mean is this and the standard deviation is this. How to calculate the first standard deviation? you can use this formula. Mean plus standard deviation, which is your mean is 394 plus 147 and 394 minus 147. So whatever the values are, let's say we'll calculate the values. 394 plus 147, which is 541, and 394 minus 147, 247. So this means within the range of 247 to 541, 68% of the data points are lying. Of course, these are just 5 records, right? So getting 68% is very difficult, but you can see these 3 dogs and some portions of this dog as well. So I mean, just imagine 68% means if you have 100 dogs or 100 records, 68 records will fall within that range. Now, in case of 5 dogs, we don't know like what's the exact number, right? Because this is a living entity, right? So we cannot calculate 68%, right? So just imagine that way. Similarly, 394 plus 3 into 147 is basically your 3 standard deviation, and 394 minus 3 times 147. So within this range, 99.7% of the records will fall. And anything beyond that is basically termed as a outlier. So using standard deviation, we have a standard way of knowing what is normal and what is extra large or extra small. Like Rottweilers are tall dogs and Dachshunds are a bit short, right? So this is basically about your standard deviation. Now, the most important topic is, some of you might be thinking that why have I used standard dev.p? What is standard dev? If you calculate standard dev of B3 to B7, the number will be around 164. What is this? Now, this is nothing. I mean, it's very simple. It's nothing but when you are calculating the variance, right? The variance is basically E10, right? Oh. Okay, so E10 is nothing but sum of this divided by 5. Now, if I copy this and if I do like this, and if I just change it to 4, you can see 27130. And then now if I do a square root of this is basically 27130, 164.71. Okay, now what is this? Let's talk about that. So a little bit difficult concept to understand, but I'm sure you can read some blogs and some articles to know more about it, but I will try to explain as much as possible. But there is a small change with sample data. Now in statistics, we have 2 concepts. One is population, one is sample. I will have more topics and more videos on how to create a sample, but let's just assume this example. Our example has been a population. A population, what is population? Population is if you only have 5 dogs records, that's my population. If you have 1,000 dogs records and you are analyzing on 1,000 dogs, that's your entire population. If you have 1,000 dogs data, but you are analyzing randomly 5 dogs data, that's basically sample out of the population, right? So if the data is a sample, then the calculation changes from n to n minus 1. So the population is divide by n. When you are calculating the variance, the sum of the mean squared error. So basically this part is now n. So this part is n, right? This part. And in terms of sample, it becomes n minus 1. As simple as that. A sample divided by n minus 1. So in this example, instead of dividing it by 5, this particular piece, we are just doing divided by 4, which is n minus 1. And then taking the square root will give me that 164, which is your new standard deviation of the sample. So if this is a sample data, the standard deviation is 164. If this is a population data, the standard deviation is 147. Now there is a theory behind it. One simple theory that I'm not sure if you will be able to understand this or not, because it's little bit difficult concept to understand. I recommend you to go through multiple blogs to understand it. Okay. Now this is one of the explanations from Quora, is that why n minus 1 and why not n? This is actually Bessel's correction. The idea behind that is more unbiased measure of variance than the usual definition. Simply just imagine you have a bookshelf. We have 5 books. Okay, 6 books in this example, and the total thickness is 158. This means that the mean thickness of the book based on first 6 samples is 26.3 millimeters. Now just imagine you take out one book and you found that the book is 22 millimeters thick. This means the remaining 5 have a total thickness of 158 minus 22, which is 136. Now you measure the second book, the second degree of freedom, and you find that it's 28 millimeters. So you know that the remaining 4 books should have a total thickness of 108 millimeters, right? Similar fashion, you take the third book, the fourth book, the fifth book. While taking the fifth book, you already know that the remaining last book is having some millimeters thickness. That means we don't need to calculate the sixth one. We don't need to have an assumption of that. So that's the reason we have this concept of n minus 1 for a sample and n for a population. Okay, this means that you have already measured n minus 1 objects, and the nth object has no freedom of, there is no freedom of change, right? So that's the reason we don't need the nth element for a sample case. Okay, the second technique is going to be detecting outliers using box plots. I already told you what is a box plot. Box plot have 5 different, 5 measures, 5 important characteristics. One is your mean, median, Q1, Q3, and max. Okay, sorry, not mean, my bad. Mean as in minimum, max as in maximum, median as in the 50th percentile, 25 percentile, and 75 percentile. You can see this graph, and these are the 5 characteristics of a box plot. And it definitely, when you are plotting a column, you will definitely be able to understand the outliers. You can see the outliers here, right? Now, there are some advanced topics as well, like clustering techniques. You can use DB scan clustering, k-means clustering to identify whether you have some outliers or not. And there are some ML algorithms to deal with outliers. So we will be talking about these topics in some of the future videos. Let's move on to the code part. So here you can see the standard deviation technique. I have just imported the NumPy, Matplotlib, and statistics library. Here I have initiated a data which is random, np.random, and then you can see the random data 33, 11, minus 13, minus 3, something like that. Here I've defined find anomalies data, and what I'm doing is I'm creating a list. I'm calculating the standard deviation, calculating the mean, and I'm doing anomaly cutoff is nothing but standard deviation, 3 times standard deviation. I'm taking plus minus 3 standard deviation, right? So minus cutoff and plus cutoff. That means this is this one. So I'm taking this range, which means that 99.7% of the data will fall between the plus minus 3 standard deviation, right? Anything beyond this, if outlier is greater than upper limit or less than lower limit, it's basically an outlier. Now you can see this is how the data looks like, random data. And if I am running the data on find anomalies, you can see these are the anomalies. So you can assume that something below minus 40 and something above 80 are considered as anomalies. You can see this. That's the normal intuition. Using boxplot, you can see very easy to do. I just have to call the cbon library.boxplot, data equals to data. You can see these are your outliers. Okay. As you can see, it considers everything above 75 or below minus 35 to be an outlier. I'll leave this so that you can run this code as well. And these results are very close to method 1 above, right? Very similar to that. Now, how to identify the outliers? You can see Boxplot is very similar to the pandas.describe method. Pandas.describe also gives the statistical information of the data frame column, right? It gives me mean, standard deviation, minimum, 25, 50, and 70 percentile and max. This is all about that. Okay. So what is interquartile? Interquartile is the difference between Q3 and Q1. Okay, which is your third quartile and the first quartile, 75 percentile minus 25 percentile. Okay. So that's it about today's video, guys. I hope you enjoyed the session on outlier detection, and we will also have some live use cases, or you know, explaining outlier detection is very difficult, and to do it practically, to do it on some use cases and how to handle that, it's very difficult to explain. It is all experience. You have to start with some use case and work on multiple use cases, and then you will understand how are we dealing with outlier detection. So that's it from today's video, guys. Thank you. I will keep sharing statistics videos like this, and ultimately once my statistics is done, I will create a playlist as well, so that you can go to the playlist. So that's it from today's video, guys. Thank you. Have a nice day and have a nice weekend. Thank you. Bye.